Download this code from codegive.com, link in the description below. OK, let's try to create a simplified web server in Python, heavily inspired by the computerphile spirit of getting the essentials across in a concise manner. We'll aim for a 25-ish line script that can handle basic HTTP requests. This won't be production ready, but it will illustrate the core concepts. I'll break it down step by step. Core concepts. Before diving into the code, let's clarify the fundamentals. 1. Sockets *. Think of sockets as the endpoints of a communication channel. A server socket listens for incoming connections, and once a connection is established, a new socket is created for the specific client. 2. HTTP *. The hypertext transfer protocol is the language of the web. A browser sends an HTTP request, example get/index.html http/1.1, and the server responds with an HTTP response, example http/1.1200 OK, followed by headers and the content of index.html. 3. Request handling *. The server needs to receive the request, parse the request, determine the requested resource, the method, etc. Find the requested resource, example a file. Construct an HTTP response. Send the response. 4. Threading, simplified to handle multiple requests concurrently, so one request doesn't block others. We'll use a basic form of threading. The code, an explanation. Line by line breakdown. 1. Import socket, imports the socket library for network communication. 2. Import threading, imports the threading library for handling multiple clients concurrently. 3. Host equals 127.0.0.1, sets the server's host address, localhost. 4. Port equals 8080, sets the port the server will listen on. 5. Def handle _ client, con, address, defines a function to handle a single client connection. Con is the socket object for the connection, and address is the client's address. 6. With con, uses a context manager to ensure the connection is properly closed, even if errors occur. 7. Print, f connected by address, prints a message when a client connects. 8. Data equals con.req, 1024, receives up to 1024 bytes of data from the client's request. 9. Request _str equals data.decode, decodes the received data, which is in bytes, into a string. 10. Print, f request received, request _str, prints the received request for debugging. 11. File name equals request _str.split, 1, extracts the requested file name from the HTTP request string. It assumes a simple GET request. 12. File name equals filename.lstrip, removes the leading slash from the file name. 13. If file name equals :, checks for a blank file name. 14. File name equals index.html, if the file name is blank, serve the index.html file. 15. Try, starts a try block to handle potential errors, like the file not being found. 16. With open, file name, r, as f, opens the requested file in read mode, r. 17. Content equals f.read, reads the entire contents of the file into the content variable. 18. Response equals f http/1.1200 ok / content type, text/html \n content, constructs the HTTP response. 200 ok means the request was successful. Content type specifies the content type, HTML. The double new line, \n, separates the headers from the body. 19 Except file not found error, catches the file not found error exception if the requested file doesn't exist. 20 Response equals http:/1.1404 not found /n/n file not found, creates a 404 not found response. 21 Con.sendle, response.encode, encodes the response string into bytes and sends it to the client. Sendle ensures that all data is sent. 22 With socket.socket, socket.af_inet, socket.sock_stream, as s, creates a socket object using a context manager. Socket.af_inet specifies the IPv4 address family, and socket.sock_stream specifies a TCP socket, reliable, connection-oriented. 23 S.bind, host, port, binds the socket to the specified host and port. 24 S.listen, puts the socket into listening mode, waiting for incoming connections. 25 Print, F server listening on host : port, prints a message indicating the server is running. 26 While true, starts an infinite loop to continuously accept incoming connections. 27 Con, address equals s.accept, accepts an incoming connection. Con is a new socket object for the connection, and address is the client's address. This line blocks until a connection is made. 28 Threading.thread, target equals handle_client, args equals con, address, .start, creates a new thread to handle the client connection. Target is the function to run in the thread, handle_client, and args are the arguments to pass to the function. .start, starts the thread. How to run it *. 1. Save the code *. Save the code as a Python file, example server.py. 2. Create index.html, optional create an index.html file in the same directory as server.py. This file will be served when you access the root URL, example http://127.0.0.1:8080/. If you don't create it, the server will respond with a 404. Example index.html. 3. Run the server *. Open a terminal or command prompt, navigate to the directory where you saved the files, and run the server. 4. Access the server *. Open a web browser and go to http://127.0.0.1:8080/, or http://localhost 8080/. You should see the contents of index.html, or the 404 error if you didn't create it. You can also try accessing other files, like http://127.0.0.1:8080/my_file.txt, create a my_file.txt file first. Important notes and limitations *. Security *. This is not a secure server. It's vulnerable to various attacks, example path traversal. Don't use it for anything serious. Error handling *. The error handling is very basic. A production server would need much more robust error handling and logging. Concurrency *. The threading is very basic. For a real server, you'd likely use a more sophisticated concurrency model, example Asyncio, Gunicorn, UWSGI. HTTP compliance *. The HTTP implementation is minimal. It only handles very simple GET requests and doesn't support many features of HTTP, example headers, cookies, different methods like post, put, delete, etc. File serving only *. It only serves static files. It can't run dynamic content like Python scripts or PHP code. Asterisk no input sanitization. Asterisk the server does not sanitize input. Supplying malicious file paths can expose files you don't intend to share. Further exploration. Asterisk HTTP protocol. Learn more about the HTTP protocol. Read the RFCs, request for comments, that define HTTP. Web frameworks. Use a web framework like Flask or Django. These frameworks handle much of the boilerplate and provide features like routing, templating, database integration, and security. Asyncio. Explore asynchronous programming with Asyncio in Python. It's a very efficient way to handle concurrent requests. This simple server gives you a glimpse into how web servers work. By understanding the fundamental concepts and building upon this basic example, you can delve deeper into the world of web development. Remember to prioritize security and follow best practices when building real-world web applications. Good luck.